happens when AI meets the real world? Technology is the foundation. Every revolution reaches an inflection point. This is ours. It's your curiosity, your vision, your determination, and your relentless pursuit of pushing boundaries that's made this happen. We're in the golden age of AI because of your ambition, making AI thrive in the industries we all rely on. Together, we're defining the next phase of AI.
Please welcome to the stage Chief Revenue Officer at Nebius, Marc Boroditsky.
Good afternoon, everyone, and thank you for joining us. As the voice of God just shared, I'm Marc Boroditsky. I'm the Chief Revenue Officer here at Nebius. It is my great privilege to welcome you all to our first Nebius Inflection. Okay, I'm not going to bore you with yet another AI keynote claiming that the entire world is going to change because of AI, that AI is making things move faster than ever before, that the opportunity is massive in front of you. As a matter of fact, every week we hear announcements for new models, new benchmarks, new agentic frameworks. Sometimes we hear all of them on the same day or even in the same hour. We're actually at an interesting point, and I think you all know this, that AI can shift from being a tool to being something that does amazing things that will shift industries. But everyone in the room here knows that. What we don't need is another speech about the size of the opportunity. We need a more honest conversation about what is actually happening on the ground now. Because a lot is working. Also, a lot is not working. And a lot is still messier than people tend to admit in a keynote on the stage. That has to change. That is, if AI is going to go from experiments into systems people can depend on, that requires us to move to the next level. That is why we created Inflection. Not as another conference, not as another product launch moment, and not as another place to make a set of industry announcements. We created it for the people that are doing the work, the operators, founders, researchers, infrastructure teams, investors, enterprise leaders, and builders taking AI from possibility into production. Because inside companies today, AI is already ahead of the decisions being made about it. Teams are building agents, multi-agent automations, and incredible new workflows. Some approved, some shadow AI. But all of it points to the same thing. People are not waiting. And that is where the work gets real. The demo works, the agent looks impressive, the first model call feels magic. Then it touches the real world. The workflow, the internal data, latency, SLAs, governance, and the finance team asking why the bill just doubled. That's when the real cost shows up. And I don't mean the invoice. I mean the bill for AI at scale. Because once AI moves from pilot to real usage, the question changes. It's no longer about, can the model do it? It becomes, can the system do it reliably, fast enough, safely, at a cost that makes sense? Can we evaluate it when something changes? Can we see what happens when it goes wrong? Can we govern a multi-agent swarm to prevent it from doing harm? And can we prove the value is greater than the cost? How organizations answer these questions is what separates the companies that will define the decade from those that won't. The first wave was about scale. Token maxing. More prompts, more context, more reasoning steps, more loops. But reality changes the metrics. What comes next shouldn't be about more tokens. It should be about making them count at a cost where the math works, at a quality users trust, at a velocity that changes business. The team that wins the next chapter aren't going to be the teams burning the most compute. They're going to be the teams that turn compute into outcomes. Think value maxing instead of token maxing. Value creating production AI at scale is the next great inflection ahead of us. But technology on its own doesn't create inflections. People do. The future won't be predicted into existence. At Nebius, we see our purpose as simple. Help the people who will actually build it. And those people are in this room. Researchers and operators, founders and enterprise leaders, infrastructure and application innovators, each contributing a critical piece of a much larger ecosystem. We believe no single company will bring the full potential of AI to the world alone. And that's what makes gatherings like this one so important. Throughout today's program, you will hear perspectives from the most interesting and leading minds in AI. You will hear about where technology is headed, what challenges still need to be solved, and what it will take to move from experimentation to production at scale. We hope these conversations challenge assumptions, sharpen perspectives, and inspire new ideas, and that you take full advantage of the extraordinary group of people gathered here today. Many members of the Nebius team are here as well, not just to present, but to listen, learn, and collaborate. And as we move through the day, I encourage you to engage fully. Ask questions, share your experiences, challenge conventional thinking, and take advantage of the opportunity to connect with this extraordinary group of leaders gathered here. So thank you for being a part of this. Before we get started, I'd like to share something that means a great deal to us here at Nebius. NVIDIA and Nebius have been building together from the beginning of Nebius. And I want to share a special message from Jensen Huang.
My friends at Nebius, congratulations. What you're building is extraordinary. Data centers are becoming AI factories. They turn energy into tokens, and tokens into intelligence. AI factories are the new infrastructure of this era. They must be built where people live and work and create, region by region, community by community. The infrastructure must live where the demand lives. This is what Nebius is building. You started with deep cloud engineering DNA. Then, you rebuilt your platform for the AI era, scaling from one data center to gigawatt-scale AI factories in just 2 years. NVIDIA brings accelerated computing, networking, systems, and inference software. Nebius built a full-stack AI platform for developers, startups, researchers, and enterprises. Together, we are proving that the world needs AI infrastructure everywhere, and building it locally is the only way to make it work. The build-out has just begun. NVIDIA is proud to partner with Nebius as you build the infrastructure of the AI era. Congratulations, and have a great inflection.
Please welcome to the stage co-founder of Nebius, Roman Chernin.
Okay, I thought that Marc will introduce me, but they changed at the last minute and gave all the control to robots and Jensen. But we know that Jensen in control of everything. Okay, thank you for coming and for opportunity to talk about what we built in Nebius, what we think we already delivered, and what is the next for us. And our industry is obviously in the inflection point. Over the last few years, we showed, actually you showed, what AI can do. But now we together need to prove that AI can create the real economical value. To reach AI's true promise, we need to create the real value for organizations and humans. And actually, we need to build healthy businesses with the healthy margins, not just show the beautiful numbers in revenue and big investment rounds. This is once-in-a-life opportunity, and we need to deliver. And here is the bad news. To deliver, you need to go and figure out the boring infrastructure details. This is dirty work, the unsexy part of the work. It's one thing to have a nice prototype or idea. It's another thing to overcome the complexity of real production and the scale, and keep product as beautiful as we showed at prototype, but reliable. The company that started with Anthropic needs to shift towards open source models to meet unit economics and really grow. Agent that works nicely in prototype when goes to scale compounds the problems and actually fall apart. Talented researcher that quit the large hyperscaler with a brilliant idea to build his own or her own lab needs infrastructure that will just work. And that's why we developed Nebius. We want to help builders when they scale. When we looked at the market, we saw the false choice. On one side, established hyperscalers with a lot of services, global reach, but looks like they were designed and built in the previous cloud era. They were not optimized for AI workloads and AI developers. They built AI services onto legacy infrastructure, and their modus operandi was always to lock in developer in the closed services with a complex billing. And not to say that they have a permanent conflict of interest. They can allocate more capacity for their internal use and less for cloud customers. On the other side, so-called neoclouds. I told many times I hate this. A new category of bare metal providers that built for AI workloads, but often they are not reliable. And to be honest, builder experience is poor. people who build it, more system integrators, they not real developers. So we thought that both choices have real constraints. And we believe there is a third path, a new category of the product. Scaled cloud for AI. Built from our first principles. First, AI specialized. We build and optimize only for machine learning. We don't do anything else. Full stack. The best total cost of ownership for our customers, because we go from the ground up. We build and operate data centers. We assemble our racks and servers, and we build a full stack software platform. Third is builder-first experience. We call it meet builder where he needs us. So we let developer focus on what they need to do and what they need to control and abstract the less of complexity. The fourth is openness. Actually, we're too small to try lock people in a closed ecosystem. So no vendor lock, rely on open standards, give a choice. And the last but not least, people matter. Support, customer experience, engineers to engineers relations. And we also dog fooding our platform from day one and until now. We built Nebius as a different kind of the company for different kind of the users. You know this phrase, nobody was fired for choosing AWS. So our customers also can choose AWS. But they choose to build on Nebius because it's fast, efficient, and actually can engineer it with the teams with the most demanding AI workloads in the world. We combine the scale and reliability with the performance of supercomputer. This is our motto. And let me share some examples of how we build together with the 4 kinds of customers. First, our super lab partners, Microsoft and Meta. We help them to build their internal ecosystems. Of course, they are large and capable, but they come to us because they know we can build very fast in the real constraints of the physical world. They need the largest interconnected clusters in the world, and we deliver custom racks and servers, the latest GPUs with InfiniBand, and multi-tier storage. Power efficient with unfailed reliability. People sometimes call it commodity, but we think there is nothing commodity at that scale. A fully integrated, production-ready factory, AI factory, is not a commodity. And for us, it's a validation of how we build the foundation level of AI infrastructure from the customers with the most insane demand in the world. They taught us how to optimize bare metal compute and build the foundation of AI cloud. There are teams that need move fast to exist. They need to do more with less. And they don't have large infrastructure teams that support them like in the big tech companies. So we built multi-tenant cloud for AI labs. Recraft was building a 20 billion parameter image generation model, but their training sessions stalled mid-run. So our engineers fixed network directly, patched nickel, and increased training speed by 6 times. Cursor needed access to NVIDIA B300s for their large reinforcement learning tasks. They were the first to adopt at scale the newest chips, even before the official firmware was released. So we moved fast and hacked together. And we applied these co-engineering lessons to many other customers, accelerating drug discovery for two of the most successful UK biotech startups, and dozens of other teams that develop next generation AI image generation like Black Forest, or robotics, AI for robotics like Rhoda, or video and world models like Descartes, and accelerating research like core automation. And the greatest reward for us is to hear that such a great, experienced people look at us not just as a vendor, but as a partner. We learned from those teams that real cost of training is not a GPU hour. Training at scale will break. So we built health checks with auto-healing and allocated spare capacity for clusters to achieve the industry-leading reliability and up to 2 times better total cost of ownership than some of the big clouds. And also, they need the earliest access to the newest hardware. So we hardly invest to be first and provide them as early as possible with a performance that only few providers can do. If AI Labs taught us what it takes to train a good model, the next type of the customers is actually those who taught us how to serve them. Inference is exploding. Everybody hear it. And the driver for that is AI native products that serve already millions of users and exponentially grow. To succeed, they need reliable inference infrastructure that never sleeps. But what is even more important, it enables the unit economics of their products. Hicksfield serves more than 25 million users and grew from 0 to hundreds of millions revenue just in a few months. They required developer experience that will enable them to very fast and continuously experiment. And also, they need the very efficient auto-scaling in inference to serve the spiky media demand. Brave delivers over the 16 million of real-time AI reviews every day, AI summaries every day. They started with do-yourself approach to inference, just rented the cluster and ran their system themselves, but shifted to managed platform because we could improve their unit economics. Sword Health builds AI care for mental health patients. When sensitive topic is involved, high latency for user feels like we just don't care. Using dedicated endpoints at Nebius, they could reduce the end-to-end latency of their product from above 20 seconds to below 12. So for these customers, we built Nebius Token Factory, a managed inference platform that gives access to all the models optimized for every use case. It's based on the same reliable infrastructure and orchestration capabilities that we have in the cloud. Inference optimization is a model plus system level problem. And we're combining Nebius engineering with two of the recent acquisitions that we announced. One of them is AgenAI, team based here in San Francisco. They are focusing on model level, advanced quantization techniques, sparse attention, kernel level. And Clarify, system design, orchestration, key caching. And looks like now we have quite a strong team to deliver on inference, validated by some very respectful people. The next lesson was that we are only available if customers can consume us on their own terms. Not everyone starts from the scratch and being nimble as AI natives. Enterprises, on their way to become also AI company, train and serve models. But they need not only performance, but they need trusted infrastructure. They need capabilities to add agents into existing systems and processes. Revolut, one of the largest fintech companies in the world with more than 70 million users. They have legions of AI agents that run on top of very sensitive data. They added Nebius Token Factory for what their existing providers were not effective. And together we improved the velocity of their AI development and delivered 65% more fraud detection and 41% better product recommendations. Another example is Shopify. They trained recommendation model and built quite complex agentic systems. And they use SkyPilot to orchestrate workloads across GCP and Nebius. So no lock-in, multi-cloud. MasterCard. They process billions and billions transactions every day. And they integrated Tavili, another recent acquisition, the Nebius Agentic Search, into their existing flows. So now they can detect money laundering not only based on the historical patterns, but using online signal. The result, higher detection rate and reduced reaction time. This happens with ecosystem of our partners, because it's not only how you build the product, but who helps customers to extract the value. So we very helpful to all our partners who took a risk to bet on us early. The top challenge for a large organization is not the technology even, it's operational model and compliance. So we built our platform with built-in security, observability, cost control, and compliance. And we also give enterprises multiple ways to consume through console, API, and SDKs with well-documented recipes. And no lock-in, 100% open source standards, and integrations to make multi-cloud work. Teams can integrate Nebius with whatever they already have and build with confidence. We shaped Nebius for different types of the teams with different types of engineering requirements. Let's look at this. At the foundation, the latest and greatest GPUs running in our own service and racks. Above that, a full cloud platform with powerful storage, auto-healing, observability, everything tightly integrated for zero performance loss. With set of ML tools, including our own Slurm and Kubernetes operator, serverless, and other services. And on top, the AI runtime, Token Factory for inference and fine-tuning of the models with system-level optimization and model-level optimization built in. All that with multiple ways to consume: security, compliance, and observability. One platform to serve any type of the builder. AI product developer to experiment and grow their product. ML engineer and scientist to spend their time on building and not configuring the cluster. Enterprise teams to run AI at scale with control. Nebius got there thanks to all the great customers we had privilege to work with and learn from. But that's not all. Everything we just showed and talked about is what we are growing now. But we want to be ready for what's coming next, and maybe we don't know all the details yet how to deliver. This is agents, new agentic world. Let me share how we think about how the future of AI infrastructure can look like. Agents are growing exponentially and changing our industry again. Customers want the agent to complete the task at a cost that makes product viable. Tokens will become the next infrastructure layer. Outcomes will be paid, not tokens. This creates the new requirements to the cloud, which we need to address. An agent is not just one optimized model call. It's a loop. It plans, calls tools and models, observes results, retries, and continues until the task is finished. Today, it's easy to prototype an agent. You can connect a model to a few tools and get things working. But production is different. Running one agent once is not the same as running thousands of agents for thousands of users in the organization. At scale, small mistake compounds. Looks nice, 95% success rate per call converts to total failure. One bad plan can burn 10 times more tokens that we budgeted. So what should the cloud infrastructure be? First, of course, it needs high-performance inference. Fast, cost-efficient, serving many calls per task. Second, grounded data access. Real-time web search, extraction, and research that gives context to the agent. Then orchestration. We need to organize routing between the models and tools, retries, state management, durable execution, and tasks that they can run for minutes and hours. And of course, observability and evals. We need to collect the full traces of what agent planned, what it did, which tools were called, what failed, what it cost, and what is the outcome. And of course, control and safety, permissions and boxing and cost caps. That is the shift from stateless model serving to agent runtime infrastructure. But when the infrastructure is in place, we can start the next loop. Every agent, when it runs, produces a ton of data, plans, traces, costs, and outcomes. And when we capture all that data, we can start improving agents systematically and continuously. The same way how today we optimize the inference endpoints. We can optimize routing, we can improve prompts and tool calling, we can reduce the cost. So the cloud platform becomes not just where agents run, it becomes the system that makes agents measurable and continuously better. There is one more shift. In the cloud, a new persona emerged, the agent as a user. Cloud platforms were built for human users. Developers who read docs, click in consoles, deploy and debug services manually. Agents need a different cloud interface, API first, programmable, and observable. We in Nebius started moving there. A year ago, we made Nebius API available through MCP, so agents could interact with platform. This year, we are working on Nebius Agent Echo, which knows how to execute complex tasks across our infrastructure. But the deeper point is workload optimization. Agents behave differently, not like humans. They call API continuously, run many steps in parallel, retry, and optimized for cost and efficiency. That requires low latency APIs, efficient scheduling, cost controls. Why I think Nebius can build it? We are vertically integrated from hardware to APIs. So we can optimize agentic workloads across the full stack and achieve the results. The goal is simple. We need to make Nebius a cloud that agents can use effectively. And what is really exciting, this is a greenfield. Agentic AI will be a new workload for everyone, for every player. There is no decade of accumulated experience. We see the new types of developers, the new type of the applications. Everyone starting from the scratch. And when everyone starts from the scratch, the advantage goes to those who can move fast and co-engineer. That's us in this room. To provide a real value of AI products, it won't be easy. But you get what you do. And the builders can solve this problem. Take impossibly hard problems and solve them. And we in Nebius will do our best to hold you back. We continue to build on pace, scaled cloud for AI. And with that, let me call to the stage Arkady, our CEO, the one who pushed us to the limit. And he will tell in which dimensions he pushes us.
I just want to summarize actually what Roma just said. Just maybe a little bit add one thing. It's just a couple of slides. It's not a big presentation. So actually, what Nebius is about, what we are doing. Nebius is building a platform, a compute platform. We build our own data centers. We build our own racks. Everybody knows it. Recently, we started going a little bit down the stack. I had to do something on the energy level of grid generation, the Bloom contract, and so on. So this is the basic hardware platform. On top of it, we build cloud, we build inference, token factory, and now we're building agentic layer. These are the tools which makes Nebius itself. So Nebius is a compute platform and tools for application for developers of AI applications, for those who actually create AI. So Nebius is just a tool. What Nebius is not doing, Nebius is not developing its own models, and Nebius is not developing its own apps. It's our dear developers or clients who, using these tools, using this compute, build these magic things, be it consumer apps or enterprise app applications, which actually generate all the value in then real industry. And this is where AI actually, we expect where all this value will be created, where everything will be, I don't know, 10 times faster or 10 times cheaper or 10 times more. And if it happens, then we have all the ecosystem working. And we're very close to this. So Nebius is here, just to state this. Roma told about our two-dimensional space. We're building the product, software product mostly, which is bare metal, cloud, inference, agentic, and we develop it for different kinds of clients who needs different things, who think differently, who speak different language, bare metal or buying GPU hours or tokens, and it's different kinds of, it's developers or project managers now. It's much more people than we're using a traditional cloud. So we're building in these two dimensions, but there's one more dimension. And this third dimension is scale. So we're building these things at scale. We started less than 2 years ago with a small 10-megawatt data center. We said that we're running more than 200 megawatt now. We recently said that we will be at 800 to 1 gigawatt of power, running power by the end of this year. We said that we already have reserved, contracted 3 gigawatt of capacity, and we said that by the end of the year, it will be more than 4 gigawatt. We're going there, we're very close. So this is the scale. But scale, it's measured in megawatts, gigawatts. It could be also measured, where we're building. Almost forgot. We're building all these megawatts and gigawatts in Europe, Middle East. It will be India and Asia Pacific soon. And of course, majority of all of our built and growth is here in the US. And what is important, of those 4 gigawatts we have contracted now, 2/3, it's our capacity. It's land, power, shell of our own. It's not leased. So we build a pretty big system. So this capacity, again, its scale could be measured in gigawatts. It also could be measured in number of GPUs. Here is it in one H100s, but it doesn't matter. The scale we're building is hundreds of thousands and millions of GPUs. How many companies today provide hundreds of thousands of GPUs in a publicly available cloud? Well, there's the 3 hyperscalers, I don't know, and us. Maybe somebody else, I don't know. So we are building one of the largest publicly available AI cloud. This is the scale. But this scale also could be measured in dollars. There is gigawatts and gigadollars. We were happy to start with $2 billion 23 months ago. Then we raised, it was actually enough for us to start reserving all this capacity, because to reserve, it's just 1% of total capex. Then we raised billions last year and started building these data centers. We reserved tens of billions this year, and it will allow us to build our gigawatt this year of GPUs. And now we're thinking how to get to hundreds of billions of dollars. Up to now, we were pretty creative and efficient in raising this capital. We were one of the first, or the first actually, who started this prepayment model from many customers, which helped us to bring cash to build. We were one of the first with this huge backstop contracts, which allowed us to finance our build cheaply. And I can tell you, there is also our converts and other traditional instruments. I can assure you that we will continue raising as creatively, as efficiently as we did, and there will be some announcements coming even very soon. But it's unlimited growth. We need more and more. It's hundreds of billions of dollars to build. It's gigawatts to build. It's millions of GPUs to build. It's a huge scale production. And I would say that, yes, we build in this three-dimensional space, the product, customers, scale, but there is a fourth dimension. Like time, you cannot put it on a graph. But this dimension, actually, it's the story of the company itself. Next month, we will be 2 years old. We have created this company. All the talent, we managed to collect people who came to us, who actually, it's thousands of people now. So it was also, again, we call it the fourth dimension. And using the name of this event today, we decided that we should inflect, and we officially stopped calling our company a startup from today. Again, we create the product, we create it at scale, and we create it for customers. And it's customers who actually make it all make sense. And I think it's the time to listen to some of our customers.
Basecamp Research is building the Internet of Biology.
This has worked! Yes!
RoboForce is building robo-labor that take on the things that humans shouldn't have to do.
We're trying to improve professional communication.
We are building foundation models to uncover new biology about the brain to change the course of dementia.
We're trying to give regulated industries the ability to accelerate their software development.
We design a new molecule and put it in the market in less than 24 months. That is absolutely insane. When you, oh yeah, it's going to take 7 years to create a new molecule. No, it can take 24 months.
One of our main technical challenges is to actually do the proper context engineering, to not bring everything mindlessly into the context.
Pharmaceuticals usually takes around 10 years and $2 billion. We had to think about the data, the model, and the infrastructure.
Who can be the fastest to provide compute at a really large scale?
And that's where Nebius comes into play.
When Nebius became important is to really scale our AI safely.
Thanks to Nebius, we were able to scale our model in a matter of weeks.
We could reduce the time from months down to just a few hours.
You guys support us at the same speed that we wish to experiment at.
The speed is incredible. Using Nebius, we reduced by about 70%.
What would usually take us 2 to 3 weeks, we could get done within a week.
When we started using Nebius, we were seeing our P99s at 400 to 500 milliseconds, which is phenomenal.
We are talking to them actually constantly, like almost every day.
I think it's a very exciting time to build right now. There are chances to build something that is used by a lot of people.
By 2030, I expect we will see truly great advancements in biology across all of the domains.
We are going to need an exponentially higher amount of compute to take us to the next level.
Find people that are on this journey with you because they believe in the mission.
Very exciting journey, but just getting started.
Please welcome to the stage Executive Editor at The Information, Amir Efrati.
Hello, everyone. My name is Amir. Great to be here. This is a great touching off point from the agentic layer to discuss how customers of Nebius, real companies, providing products to AI customers, are experiencing the moment that we're in. So, without further ado, let's welcome the rest of our speakers. Hey guys. All right. So when Nebius first came to me with the idea for this discussion, I thought it would be quite a different event than maybe what we have today. I thought it would be kind of case study after case study of companies that are doing things that they thought they could never do before or that they couldn't even do 6 months ago. That's still very much the case, and there's plenty to talk about there. But I think we're in a bit of a let's call it narrative shift, if you will. A lot of chatter among CIOs and CTOs about runaway costs, lack of cost controls, and it really seems to be dominating the conversation. So I'm really particularly excited to talk about that and what companies are doing. So let's kind of set the stage for that discussion. And I guess we'll just sort of go in order. I want to hear from each of you. We'll start with Nikita from Databricks about just how you view this particular moment. Is this sort of a temporary blip, temporary moment of review, reconsideration, retrenchment, or is it just sort of like a matter of a few weeks before the next models come out, we'll sort of forget about all that and we'll like race ahead toward like how much of the API at Anthropic or OpenAI can we use, how much of our money should we give to Scott and to Devang and the agents there. Why don't you kick us off with that? And tell us who you are.
Yeah, so my name's Nikita. I work at Databricks. Previously, I founded a company called Neon that was acquired last year. It's in the downstream consumption of all the AI coding agent, providing infrastructure for modern apps. At Databricks, I'm running an operational database, what Neon has become, and also an application platform. And so I'm very, very closely connected to all the code generation systems. So here, to answer your question, I think there's like a Databricks perspective, like what people do, like I said, it's a gigantic engineering organization, and then what our customers are asking us to do. So let's start with the customers. Customers want cost controls, you know, obviously, like we just went through a small phase of token maxing, and I think we're still kind of in it. But then the wheels starting to come off at various places where it is important to leverage AI as much as possible if you are an engineer. But then there's also wasteful spend as well. And so people want to see what's going on. The Databricks perspective is that if you can put AI gateway through the AI consumption, so it's a purely infrastructure point of view, saying, hey, send our your AI consumption through our AI Unity gateway, and we'll tell you what's going on. And then from that point on, it's like, okay, well, from that, you know, if you want to, you can shift into other models. We will host them for you, and yada, yada. So that's purely a Databricks perspective for their customers. Internally, the AI budget is unlimited for engineers. So token maxing still exists. People can bring their own AI tools or can consume, like mostly people are running Cloud Code or something like an internal version of Devang, I would say. Something that resembles Devang is probably. But I think where it's heading is, I actually don't know. So I think we're going to have more visibility in how productive engineers are. And when we start looking at the overall software delivery pipeline and seeing what the bottlenecks are in there.
All right, Venki from DataRobot, take us away.
Sure. I'm Venki. I'm the CPO for DataRobot. We've been really focused on how to get enterprises to actually really retool the way they work with agents, and so sort of like you know how agents have now changed how coding works. We're thinking about how to do core enterprise workflows like business planning or safety or you know things like that, operations. So what we found on the cost side is that when you start seeing the stuff in production, you just start seeing it. It is no longer sort of like a, hey, it's a $30 extra subscription, right, per user. You're starting to look at millions of dollars, and suddenly it's a big line item. And so when the I becomes large, you're going to start asking questions about the R, right? And so that's kind of what's happening right now. It's everyone's sort of relitigating, hey, is it enough to just put an agent and call it good? Because it costs a lot, but what am I really getting for on that side? And so, our perspective is you have to really, on the I part, you really have to sort of think through cost is a very core design principle up front. So when you're building the agent, designing the agent, evaluating the agent, you got to think about that. Then you got to think about how to get the correct the models, and then running them at runtime. Nikita talked about the gateway, sort of moving to different models based on intent to different models. So you're actually choosing the lowest models. And when you are running your own models, self-hosting your own models, are you getting the most utilization? So it's really a big stack of work you do on the investment side, and so that's important. And on the ROI side, on the return side, you got to pick interesting problems, right? You just can't take every workflow you already have and stick an agent next to it and sort of expect returns. You really have to sort of go native and sort of think through how to revisit your entire business process now that the agent's there.
Well, we'll kind of go deeper on that in a second. For Marc at Nebius, I was just on the way over here thinking about this moment that we're in, and it really feels similar to where we were 10, 15 years ago with the public cloud. I was writing about customers of AWS in particular that were like, wait a minute, I just spent $20 million more than I expected to this year. Back then, $20 million was a lot of money. And so it actually feels like a very similar moment. I don't know if you find that to be true, but where do you see us in this moment when it comes to applied AI and the kind of costs that we're seeing among the customers?
Yeah, I think
cost problem comes with the scale. So when you start
skill or scale?
Scale.
Scale.
Yes. Like it's very easy to create prototype, like Roman showed, see some results. But if you scale this prototype to hundreds of users, your token economics kill you, and you need to apply some technologies to make it more reliable and cost effective. Like I can give you one of the examples. Like when we were a year ago, when we were created an MCP for our cloud. Like you can just take this MCP attached to our cloud and ask some questions like what some user did in our platform. And with MCP, it took like 15 minutes and consumed 1 million tokens just to answer this question. When we updated it to Echo, which has like a lot of context about our information, about our APIs, about everything, the same query like took seconds, and agent spends like thousands of tokens. So it's really important not only to use models, but also to optimize data layer and provide more and more efficient context to the models, and it will reduce your cost drastically. And that's what we see in our platform, definitely.
And for Scott, I'm guessing some of this noise around the backlash to some of the spending that we're seeing out there is probably music to your ears as somebody who's not only kind of built his business and product by sort of abstracting the model providers, but also being very outcome focused, outcome first. Tell us about this moment. How are you experiencing this moment? You're seeing all these headlines. You're seeing a lot of customers and CIOs and CTOs discussing about it, about these runaway costs. Sorry. What is it like for you?
Yeah, for sure. So I'm Scott. I'm CEO of Cognition. So we build Devang, the AI software engineer. Pretty strongly agree with all the points that folks here have already made. Like you're really seeing prices and just spend increase to a point where all these CIOs really care about it, obviously. And I think at a really high level, the way I'd put it is like, guys, like AI works. Like it's just clearly worth it. When we talk about, okay, you're getting this kind of efficiency gain, or you're able to do so much more. The GPUs are expensive, but they're not that expensive, right? Like you are getting, relative to the tokens that you're paying, if you're comparing that to how much more capacity you have or how much more output you're doing, it's very much, the math is just very clearly there, relative to, for example, what you're paying your humans and how much more, every single human on your team can do, right? I think the thing that that people are often really focused on is, okay, well, how do you really measure and optimize that? And how do you think about that in terms of outcomes, right? And so, writing 10,000 lines of code or something, it is much, much cheaper for any of these models to write 10,000 lines of code than for a human to write 10,000 lines of code. But it's almost, it's almost like managing agents in the same way that managing humans is a thing, which is those 10,000 lines of code, if they were totally useless and on a task that you never actually shipped or built or whatever, then that was a waste of money entirely, right? And so it's much more about thinking about, okay, what are the actual outcomes I'm driving, right? And people talk about Jevons paradox, which I would say are very actively seeing in the field today. Every single company is building way more and they're shipping way more software, but what they want to know is, okay, well, what are the concrete returns that I'm getting out of shipping way more software? How do I measure that, right? And maybe it's that I'm getting my products to market faster and then I'm doing more revenue that way, right? Maybe it's that I'm able to give customers a way better experience, and like, let's figure out how that kind of maps to this. Or maybe it's that, all of these things that I'm paying for internally, or the software that I'm paying for internally, I'm able to build faster and better and smarter versions of that, and that's why it's worth more. But it's really, I think, less so about like whether the literal pound per pound is there, and more so about making sure they're directing it towards the use cases that actually affect their bottom line.
You make it sound pretty easy. Obviously, I don't know how many folks here are at extremely large enterprises where there are lots of fiefdoms, lots of different spending centers, cost centers, different divisions doing different things. One of the solutions in the earlier paradigm of the public cloud was like centralizing, having some sort of central decision making around spending so that it wasn't just every team doing whatever they want. So can we get it a little bit into kind of some of the organizational hurdles that you're seeing companies try to tackle here? And then also, we just wrote a column last week at The Information around some of the basic steps that companies can take to try to lower their costs. You can read about it there. But a bunch of folks are now talking about model routers. There's a lot of things that are easier for more sophisticated customers to do than less sophisticated ones. But for any of you, jump into that.
Yeah, no, to your point, it's definitely easier said than done. And with larger organizations, there will be compartmentalized budgets, and here's what you're allowed to spend on this, and here's what you're allowed to spend on that. I think a few things I would call out that we're seeing. One is, I think for a lot of spend, spend that folks were thinking about, outsourcing or figuring out how they pay for services or things like that. It's been kind of a very natural rotation to say, okay, well, let's figure out how we actually do way more with AI instead, right? And so that's kind of much more of a natural substitute. To your point, I mean, I actually think a lot of the big gains are actually less from cutting costs, but more from increasing output and increasing capacity. There's some work I think that needs to be done in terms of just really passing all of that through and making sure, throughout the stack that everyone on the team understands exactly where the gains are coming from. But I think you're seeing that process happen across a lot of these big enterprises today. On the point of model routing, I think it's a great point as well, which is I think what we're seeing especially is as people are thinking within the confines of the tokens that they have or the budgets that they have, obviously we see more and more that all of the models are getting better, right? And we see this in code where the absolute hardest tasks, you still want the very smartest models on, right? And so, Fable, which was just released today, there are tasks that only Fable can do. But the reality is that's, call it maybe 10 or 20% of the tasks that a software engineer is typically doing, right? For that other 80, 90%, there's naturally a question of, okay, how do I make sure I'm using the cheaper models and there are there's great open source models that will take care of 50, 60% of my tasks and do that 10 times faster and 10 times cheaper. Obviously, I want to go and make that improvement and do that. And so I think model routing is becoming a much bigger piece, and I think we'll continue to see that happen.
Yeah, can you guys, talk more about open source if you can at some point. But yeah, go ahead, Nikita.
One of the things that I think is very practical for a large organization is to build an internal tool that is useful for both coding and non-coding tasks. It could be a thin wrapper over Cloud Code. It could be something more sophisticated, but certainly it's connected to all the internal processes, usually via MCP. That is email, Slack, basically all the system where work happens. And a lot of work happens, obviously, in generating code, but also in deploying that code and running CI/CD process. So what this does is now you have a more, because everybody's using that tool, and of course, in order to do that, the tool needs to be useful. Inside Databricks, this tool is called Isaac. Inside RAM, it's called Incept, I think. And of course, you can just buy this tool off the shelf. It will be called Devang. But once you have that, you have all the telemetry coming out of this from the all AI usage, which is not just your calls into AI, but actually work is done through that tool. And once there, then model routing becomes a real option. And then you can start piping certain usage through cheaper models. And basically, once you're on the consumption path, and then you're on a consumption path end to end of every work that's happening in your organization, you can digitize it, and therefore you can optimize it, by piping to open source models, by choosing model, lots of things can be happening. You will also find out that that the bottlenecks might not become models at all. For example, modern CI/CD process is kind of broken. For a while, at Databricks, we had we're now piling PRs. Right? They're waiting for either code reviews or they're waiting for the CI/CD process to complete. We have all these charts going up and to the right of how many PRs in parallel are stacked up. So I think we'll start optimizing those things as we see them end to end. And the first kind of prerequisite is to build a tool that where work happens for your organization.
So maybe I'll take it in a different direction because you started with organizational. I think there's sort of two models we've seen. I think a lot of it is bottoms up. People sort of picking up tools and sort of using them. And I think generally they end up automating and speeding up what they do themselves, sort of the productivity gains you get from the individuals. but those are really kind of hard to measure. You can certainly be qualitatively, but it's kind of hard to measure because you're like, I did a better presentation, higher quality presentation, but it's not clear sort of like how to measure that. So I think there is that. I think the place where I've seen sort of more success in measuring has been a little bit more top down. So at Chevron, who's a customer of ours, they have a whole team that's really reporting to the CEO that's working top down to say, how do we do AI-based retransformation? And they're working with us to actually take on these really hard problems. They have a facilities of the future. There's a reference that just went out on our website. But they really talked about like, hey, how do we pull things together that previously could not be done? And that's sort of the idea of like, people have talked about role collapse and time collapse with agents because things go much quicker. You can sort of do different things. And so we found, getting a model that is sort of, a traditional LLM that does reasoning. There is cuOpt, there is, Physics Nemo that does other kinds of physics modeling. Pulling those together to actually solve a really hard plant safety problem, that's what they found. They were like, hey, look, now we're able to literally not send humans into gas leaks because they're able to now, manage their drones and safely, right? And so it's a very different way. And so they find that to be a very interesting use case that really sort of changes the economics for them in terms of what they can do with their own work. So it's not, how many engineers or how many individuals, but they're able to really measure, look, we're build a new facility of the future that has less people out in the gas leak, right? So it's a different kind of approach, which is top down.
Yeah, I mean, I guess I know that there's no silver bullet here, but I think it seems like there's a pretty big difference between companies that maybe are extremely sophisticated, run a lot of databases, know how to throw AI on top of it to create applications, and those that maybe are in heavily regulated industries, are very old, gigantic, need a lot more hand-holding. So I think everyone is really trying to understand what are the best models for measuring, outcomes, for measuring ROI, like what are the best examples that exist? Are there, unique opportunities? OpenAI and Anthropic can say until they're blue in the face, this is how you should do it. But are there, startups that are starting to come up and help and provide the right kind of dashboards? Or is it going to be the legacy, I don't want to say legacy, the OGs of AI, yourself included, or the Palantirs of the world, or the Salesforces of the world, that are going to insert themselves and say, we are the intermediary here. You need us to make sense of this all, to know how to route to different models, to know how to use open source in addition to everything to achieve your outcome. Just tell us what you want to achieve, and we'll achieve it for you. So I'm just trying to figure that out, because like there's this massive debate about, oh no, you just need a really good set of databases, spin up a lot more databases, throw AI on top of it. I mean, ask Snowflake, they've been saying a lot of this recently, and you're off to the races. You don't need this intermediary layer. It's just this massive debate in the industry right now. I'd love for you guys to weigh in on it.
Yeah, I can. Actually, this is our internal pain right now, because we are enabling AI in our teams, and data layer, I believe, is super important to be optimized for agents. Like, well, what I'm talking about? I'm talking about you can get great productivity with creating your own LLM wikis for your personal use. But when you scale it, you realize that there is not much technology today to help you with. Because you need some semantic layer to show, to guide agents. What is company context? Like, what is company terminology? What is the company legacy? What is history? What are the processes? And all of this allocated in scarce data sources inside company. Plus, half of the information is people heads in emails, in chat. So you need like different semantic layer which will aggregate all these data sources, like just to scale. Like, you can get a lot for personal productivity. Like my personal Claude, it can create great analytical queries, like better than anybody in our company, to be honest. But like to scale it, like I can't scale it because like it has my own context as well. So I need something in between to connect all the data sources and to provide shared context to the company. So I believe companies should move to have personal context plus create corporate cortex to allow it to be super scalable. Yeah.
Yeah, I'm glad you mentioned semantic layer. We actually did a whole article on the semantic layer a couple of weeks ago. It was sort of in the context of Microsoft's Power BI and how it's trying to put more kind of walls around it, make it harder maybe for certain folks to get in. By folks, I mean having customers use Databricks or other tools to kind of bring their data from Power BI into the rest of what they're doing in developing AI applications. So I am curious for your thoughts about this and how this is going to play out. I mean, putting walls and toll gates around traditional applications seems to be happening. Companies are talking about it on earnings calls. It's sort of the beginnings of it. I don't know where it's going to end up, if there's going to be a revolt among customers or not, or if customers are able to vibe code their way out of it. But I'd love to hear your thoughts on that trend as well. For any of you.
So I would say, I think you can put the toll gates on, but I think that some people will grudgingly accept it. But I think in the end, it's not going to work out because it's the customer is going to say this is the stuff, this is my data and my IP, and they will have to sort of figure out the right thing. Whether they wipe code their way out of it, there'll be there are alternatives. They'll go to someone will say, hey, look, there's a way to make money not having those things, right? And so I think that may not be the hardest problem to solve for. I think it will go past it.
I actually live this problem a little bit because, well, think about it. Where is the work happening? Is the work happening inside an AI tool? Is the work happening in Claude? Or is the work happening in my SaaS tool?
That's right.
And so, okay, well, where does the customer want the work to happen? And at the end of the day, where the customer needs the work to happen, that's where this thing will arrive. And you can put up walls, but if the customer wants to live in Claude Code, then a competitor will offer a capability that allows you to consume everything from Claude Code. So now, okay, well, but you have your SaaS tool, it's billions in revenue, all of those things. Now, what do you do? What you do is, of course, you have to do both. And then you will allow people to do work where they want to do work. And then you need to bring AI into your product and make sure that hopefully, if you're lucky, and if you're not, you're going to be disintermediated, right? But if you're lucky, you can provide better experience by using your tool with AI than consuming that same product inside Claude Code. And I think every company, every owner of a SaaS product, and obviously Databricks is a SaaS product, and it's just a data product, but it's also a SaaS tool. They have to do both, and there's no choice really today. And then the future will play out the way it will play out.
Yeah, maybe just an example, a lot of the people in my company now use Claude Cowork and to create PowerPoint decks, right? So you're not in PowerPoint to build the deck. You're actually in Claude building the deck, and it's just an export mechanism, right? The PPTX comes out at the end, and so if you sort of put a huge barrier to PowerPoint to say you can't use this thing, then you'll use something else to
use PowerPoint.
No, we use it. That's the only thing it supports, by the way. It doesn't give Google Slides yet. So, but when it does, there'll be, we could be able to use any of those. So the idea is that you're able to use if you're working in AI, the other things become less important, and then that's where you have to compete. And you have to say, I don't think it's actually sustainable to simply put a toll gate.
Out of curiosity, what percentage of AI spending in the enterprise today do you think is experimental or not considered essential yet? Does anyone know the answer or have a guess?
I think as a function of spend, I think it's honestly a pretty small minority at this point, just because the workflows that are typically really scaled up are the ones that people are just seeing work en masse, right? And so as a function of okay, the number of use cases we can talk about, then I think there's tons and tons of things. We see this in orgs that we work with. We see this even internally. There's tons of things that people will try. We'll mess around with a couple different use cases, but obviously the ones that you find that, okay, this is going to work over and over and over, and this kind of upgrade or this kind of migration, I just know for a fact I'm going to save 6 hours for every single time I spin up an agent to go and do this. Those are the ones that get scaled up 1,000x, right? And so when we're talking about this AI boom and this massive growth in consumption, of course, there's some of that. There's a big narrative of all the people going crazy with the tokens. I'm sure there's some of that exists there. But I actually think in practice for orgs that are kind of monitoring their spend, most of them have gotten to a point where they're spending the large majority of that on real use cases. Yeah.
100%. Like, especially coding, right? Coding just blew up. Like it's so obvious for anybody who writes code how more effective they can be by using AI tools, and therefore, like, the spend on that particular category is just unreal. So I think this takes a huge share.
Definitely unsustainable in some cases. I mean, I think it was a very popular article, but we like published the internal dashboard for how Meta is measuring some of these costs as their engineers were talking about. It was definitely out of control. I don't know how big of a customer they were of Anthropic. They were probably top 4. There's probably still top 4, but I just don't know if it's that simple. Like, I think there's still a lot.
I think in engineering and sort of like, especially in coding, I think like it has sort of past criticality, right? And so it is useful, people know how to use it, and I think a lot of the use is actually is sort of directly production type work. But I'd say there are a lot of other use cases where you're not there at all. I think we see a lot of that in traditional industries, like, their adoption of AI or agentic AI is much earlier. And so I'd say a super majority of that spend probably is experimental, which is trying to find the use case where it actually makes a real difference. Don't get me wrong, it's not like they're not spending on AI. They're spending on Copilots, they're spending on Gemini, they're spending on Anthropic. So I think personal productivity, I think it's there. But I think like in terms of like, if you think about mission critical workloads where coding is one of them, then what's the next 5 that are in the traditional industry? I'd say like it's very early days. I think there's a lot of experimenting being done there.
Is there like how big is kind of the gap between capabilities of the underlying models and the harnesses that are very quickly being built around them and what people are using them for today? It does seem like, I don't know if maybe I'm just speaking for myself, I'm definitely experiencing and hearing about new uses almost every day, certainly every week. So I'm just curious to know how big of this gap, how big is this gap?
I think it really depends on who we're talking about, basically, right? And so I think like folks in
corporate America,
startups in San Francisco, for example, I think are pretty on top of it, right? And corporate America, to your point, I mean that can be months and months out, or in some cases even years out, which is a big deal. I mean, it's a good call out for the physics of how a lot of this enterprise adoption looks. And people ask this question. Obviously, a lot of companies in AI have had these like insane growth curves. And there's a question of well, how is that possible that they can grow so fast and serve so much? Is it sustainable? Is it not sustainable? And the way I'd kind of put it is, well, with a lot of these, technology has always come in waves, right? And before this wave was the cloud wave, and before that was mobile, and before that was the internet, personal computer, or whatever. I think there's a couple things going on. I think for one, obviously the mechanism of delivering it is just pure software, and so it's just much easier to adopt and use at companies. But I think the other thing, to your point, is like, it's not really okay to be 2 years late, anymore, right? And if you think about cloud adoption, I mean, lots and lots of companies just got on cloud in the last few years. They just moved their last systems off-prem, right? And it's like, all right, yeah, you're 5 years late, 10 years late, but it's okay. It's like we're making it work with what we have, and maybe would have been a little bit more efficient to come sooner, but it works out fine. 5 years late, 10 years late on AI is not going to cut it here, right?
Unless you're Apple, in which case,
apparently so, yeah. And I think a lot of the enterprises really see this as well. And so I think even when we're talking in these relative terms, it's 6 months late or 3 months late, which is a big deal, by the way, in terms of what use cases. It's worth calling out. It's still like an order of magnitude faster, I think, than many of the previous trends that we've seen. Yeah.
I would agree here, and add that I really agree that startups and AI natives are in very lucky positions. They don't have this legacy. They're starting from the scratch.
Yeah.
And like more history, more legacy, you have more internal politics you have. Like it means that you need more changes to adapt AI internally. So it really depends on more mature org you are, in worse situation you are, I believe.
Yeah, and even coding, right? Like, which is probably now the most mature AI sort of agentic AI use case. Like, if you're a company that has a large code base and a team and everything else, and you say, look, now you no longer have these different roles. There's only a builder role. It's not PM and design and engineering. You have to now reorg all the teams. You've got to figure out what to do with them, and that is not free, right? But if you're a startup in 50 miles of this event, and you're starting from scratch, yeah, sure, you don't have any of that, or you have 5 people, and it's easy to sort of get around it. But if you have 500 people, 1,000 people, there are real work to like reorg the team and how to think about planning and how to think about the work. And so, and that is the people who are trying, right? There are other people who still don't understand it just because they don't have the.
What's the oldest company that you know that's done the best at adapting?
I don't know enough, but of our customer base, like I would say Chevron, because they've been leaned in. They're really, really top-down leaning in, and it's super uncomfortable, right? They're like the plant managers, like WTF with what you're proposing here. Like I can't do any of this stuff because of regulations, but they're pushing, right? And they have a team set up to push. And so I think every company is trying to push differently, but I think we deeply underestimate how much it is to change, a bunch of work, certainly in traditional companies, yeah.
Well, I'd be remiss not to talk about the GPU crunch that your friends at Nebius and Narek know all too well. I think Marc from your team was calling out raising prices in the last earnings call. We're certainly hearing from a lot of startup founders and other kind of AI product founders that it's tough out there. It's tough out there. A lot of capacity is being reserved for really large customers. So I'm just curious, like, certainly Narek for you, but also for your customers here, like what are the tricks? Like what's working, what's not working? How do you get better deals? Yeah, what are you doing?
Yeah, that's a good question. How to deal with it? First, I believe, like if you're a user of AI, if you're not building AI, like you are very likely to have in position to use open source models. Using optimized data layer will also allow basically to squeeze more from the capacity investment that you can get from infrastructure from the GPUs. Combining multiple types of workloads, you don't need to research for all the, you will need to research for some types of the applications, but sometimes you can run batch inference where you can go and do like what Shopify are doing. They're using GCP and Nebius and preemptible instances in both places for like non-critical workloads. So there is like multiple tricks, mostly to but the main idea is that you can map your type of the workload to requirements for the compute. Like for production, like large-scale production, predictable production, you will need to have reserve. And like you can get more tokens from this reserve if you use like token factory like services, which allow you to squeeze more tokens basically. But you can also combine it with burst usage. It's definitely possible in the world, particularly if you use like multi-cloud technologies like SkyPilot or something. Yeah.
Scott, in the remaining time, I was wondering if you could walk us into the future 5 years from now and just tell us what your agents are going to be doing for us. Are we going to have IT departments anymore? Like, what's going to happen?
Yeah, so 5 years from now, we're all going to be in the metaverse. There's not going to be any physical. No, so, no. Look, I mean, I think you really see the trend continuing, and I mean, I think there's at this point, it's almost a trite saying it's San Francisco, but it's worth really like sitting on the implications of it, which is people talk about the METR study of how much work can an agent do autonomously, right? And 2 years ago, it wasn't that long ago, 2 years ago, that it was 20 seconds or something, right? And a year ago, it was like 5-10 minutes of work, and now we're talking about several hours of work. And it continues to grow at this exponential curve. I haven't seen I actually don't know what the latest number is for Fable, but I'm sure that is now another 2x higher or whatever. And if you just naturally follow at that curve and you just ask the question, well, what happens if it does continue? Then you're thinking about, okay, this model is an agent that can do months of work, right? And it's almost a different operating model where it's now like, look, let me give this agent a whole initiative. Let me give this agent an entire goal to and let the agent scope out its own project and think about how it should accomplish the objective and how it should do all those things, right? What does it look like when you're actually going in and doing that and on a scale of days or weeks or months? I think we're going to see a lot of that. And I think the cool thing about
what's going to be a month-long project that you want to do?
Oh, it's a great question. I mean, it's like today, let's say for a coding agent, it's like, hey, here's this bug that the customer reported, go and do this. Or like, hey, we just wrote a product spec for this feature, let's go and do that, right? I think not too long from now, it's going to be like, hey, like at a high level, we're just like really thinking about optimizing our architecture, trying to save money on costs, trying to optimize our databases. Devin, just take that as a whole initiative. take a look at what's going on right now, think about what you think is inefficient, and then just build everything that you think is like the right way to go and redo this. Like what are the right way to key into the database? What are the right, it's like, rather than a task, it's almost like an open-ended question. Well, what should we do? You tell me. Like, you go do the research on this, you figure this out, right? And I think we're starting to get to that already. And I think the interesting thing that comes to, obviously, is just you're getting closer and closer, I think, to getting to think of ideas and have them become reality, which is what I'm personally really excited about. I mean, I agree, by the way, we're going to be in a massive crunch for GPUs. Please, Marc and Roman and Arkady, please save some for us. But like, I mean, I think that's what we're going to see. And I think for every business out there, people are just going to be able to build so much more. They're going to be able to do so much more for their customers.
What's the longest time horizon, job, task that you've seen done that like surprised you in the last couple months?
Yeah, so we've seen people who've run Devon sessions for like multiple weeks. I would not recommend that. There's some more like meme type behavior. But no, I mean, we've seen like end to end. I mean, for example, like for some of our training runs and our projects, it's like we had projects that like, would have been full like internship projects like a year ago, like multi-week internship projects. And like Devon just does it in a couple days, and it like runs all these things, and it puts up a nice data set of its results, and it gives that to you, and it's really incredible to see.
There's an interesting thought, and like hearing all that, and it occurred to me that I grew up in the era of like various infrastructure projects, database engines, storage subsystems, companies like Pure Storage, Snowflake, Databricks, Nutanix, Palo Alto Networks, right? They're building infrastructure products. What is the defining property of those? They're really hard to build. It takes a lot of really hardcore systems engineers that live in the Bay Area. They're very contested, right? They can go work anywhere, and generally each one of those projects is like many years, right? So you want to put together like an enterprise-grade storage system, enterprise-grade database systems. That's like 5 years, right? In order to go and build it end to end. Yeah. But the other property of those systems, and they can be incredibly well spec'd, because what the API to the system is, what a database engine is, what a storage subsystem is. So I think it may be an opportunity to build more infrastructure systems, and if you build them from scratch, and then you start with a well-defined spec, then you can like design your system, not obviously one-shot it, but like think deeply how you can break down work, and then unleash an army of agents to go and build these things much, much quicker. And by the way, some of that I'm seeing right now at Databricks, but I think it's going to be like 10x, 100x.
This is a product preview you're giving us right now, is that?
No, maybe like, there's entrepreneurs in the room that want to build infrastructure things. That we certainly live in the world of opportunity right now.
Okay, cool. All right, well, we're out of time, so thanks, gentlemen, very much.
Thank you.
Thank you, Amir, Scott, Venki, Nikita, Narek. Hearing from our customers is critically important, and it's a real privilege to have extraordinary leaders and executives like we did just now on the stage. Hopefully what you heard is that the gap is real. The gap between what we want to do with AI and what we have in the way of systems, processes, tools, and enterprise readiness. And in order for us to deliver on the vision that we have, in order to be able to bring the right kind of innovator and builder and enterprise leader insights to the table so that we at Nebius can take the inspiration and understanding and turn it into the necessary inputs that we need in order to deliver on the potential of what enterprise and scale AI looks like. The gap isn't the ambition. It's between what AI can do and the systems that organizations can actually deploy trust, and depend on. And what it will require, as I'm insinuating, is collaboration across the entire stack. And not the kind that happens at a panel once a year, but one that is actually happening as we're building and sharing what we're working on, what's working, what's not, developing a common set of standards and repeatable architectures. To that end, I'm excited to announce 3 new initiatives designed to bring together some of the most experienced builders and practitioners in our industry. The first is the launch of the Nebius Customer Advisory Board. This is not merely a collection of titles, but a working group of operators, builders, and enterprise leaders from across the AI stack. The mission of the advisory board is simple: help shape the future of production AI. That's the discussion we're having here today. So it is my pleasure to introduce the inaugural members of the Nebius Customer Advisory Board. From Amy, Black Forest Labs, Cloudflare, Cognition, Cohere, Core Automation, Higgsfield, Recraft, Revolut, and Rhoda. Many of them are in the room today. As a matter of fact, if you're one of those, can you stand up? Oh, hey, there we go. Thank you for being here to stand up when I said that. Please join me in welcoming and thanking all these exceptional leaders for the partnership and commitment. The CAB is how Nebius partners with organizations like the companies that I just mentioned. Alongside the board, today we are launching the Nebius Fellows Program, a network of developers, contributors, and community organizers who are shaping what AI actually looks like when it lands in the real world. Our founding cohort spans cities from across the world. They are contributors to VLLM and CNCF and building the agents and eval frameworks the rest of us use. They run meetups, hackathons, workshops across the globe, from Tel Aviv to Toronto and Berlin to Buenos Aires and from San Francisco to Singapore. And with that, it is my privilege to welcome the inaugural class of the Nebius Fellows. To each of the fellows, thank you. And here they are. They do incredible work. I've seen some of their videos that Wakasa shared with me, and it's a real privilege to have this kind of community support. And I'm really excited about what it means as we're building towards the potential for AI. Okay, finally, the third program. I'd like to share our new Builder program that launched in preview today. This is for builders who are getting started, and for the ones who want to move faster than the infrastructure around them. People testing their agents, deploying inference, learning the stack, and turning ideas into products. You will get Nebius and Tavali credits, courses, easy access to our features, and a path to wider Nebius ecosystem. You can sign up now at dev.nebius.com. So, in conclusion, we are adding 3 important ways to learn, collaborate, and advance AI in production: our CAB, our Fellows Program, and our Builder Program. So, with that, I'd like to shift gears and now introduce another builder, Devang Sachdev, Nebius VP of Ecosystem Strategy, to share our thoughts on Agentic Inflection.
Good afternoon. Thanks for joining me today. Quick show of hands. How many of you have built or prototyped an agent so far? Excellent. Keep them up if your agent is running in production. Keep them up if there's a user to these agents that is somebody other than yourself. Keep them up if you are running not just one agent, but more than one agent. All right, so this is the gap that I want to talk to you about today. And I have a great group of people who are going to join us in a little bit to help us dig into it. But before we start, I want to set up the stage for the conversation just a little bit. So a year ago, we were asking the question, can I build an agent? And since then, models have improved, frameworks have improved, and tool use has improved. But today, the question that we're asking is, can I operate an agent? Or maybe 10, or maybe hundreds in production. See, the challenge is that most teams have prototyped agents, but very few have been able to successfully and reliably run them in production. And the reasons why are more interesting than you would think. Let me show you a real example. So we built a compliance audit agent for healthcare companies. And this agent helps compliance teams audit their standard operating policies, hundreds or maybe thousands of them, against 30 or so regulatory frameworks, GDPR, HIPAA, SOC 2, you know the rest. For today, we're going to focus on a very particular task. We're going to focus on the fact that FDA has released a new set of guidelines for AI-enabled medical devices. And the agent's job is to find out which operating procedures have been affected and file remediation tickets in Jira. So let's see what happened when we built this agent. Building the prototype was actually pretty easy. Barely took us a day. I think we had done most of the work before lunch. And out of the gate, it actually worked. It was built using GPT 5.5 as the model, LangChain deep agents for orchestration, and then Pinecone Vector DB for retrieval. Like I said, for most tasks, it just worked out of the box, or once we built it. But for this specific task with the latest FDA guidelines, it wasn't able to find the most latest one. So it used the knowledge that it had, the existing knowledge. And it completed the task, but it didn't understand fully what was the change that triggered the task. So this really isn't really a reasoning problem. This is a challenge of freshness of data. So we added Tavili to ground the agent with live agentic search. And there was just one change to the stack, this one addition to the harness. And off the bat, we saw that the agent was able to now start by finding the latest FDA guidelines, and it discovered 47 procedures that were affected by these new guidelines. It also filed probably double the amount of tickets that the prototype agent had. But two problems emerged. One, this agent also increased the coverage and the scope, and when it found the 47 findings of affected procedures, it not only found things related to FDA guidelines, but it also discovered some things related to HIPAA and a few other regulatory frameworks that we weren't intending for the agent to look at. So prioritization was not very clear, and it was left to humans to triage. And second, if you notice that this one run of just one task took about $657. I got a Slack message from our engineer building this saying, is this for real? Are we going to spend this much money on building this agent? And that's really unsustainable, especially in production, at least for this agent. So while we solve for freshness of data, we expose two new challenges. One, of overscoping, and second, of inference economics. So we tried a third configuration. We swapped out GPT 5.5 and replaced it with DeepSeek V4 Pro running on Nebius Token Factory. And instantly, the cost dropped from $657 per run to about $34. That's 95% cost savings. And this is without any post-training or fine-tuning. The scope also improved. We went from 47 findings down to 29. But yet again, we saw two challenges that emerged. Number one was the runtime actually doubled. It went from half an hour of runtime to about an hour, which was pretty long for this agent. And then second, when it filed the severity, the tickets with a certain type of severity, we weren't able to understand and explain what was the reasoning behind that severity. So the agent was largely opaque. So we continued experimenting with newer models. We continued experimenting with different models. And what we settled on was NVIDIA's Nemotron, Nemotron Ultra, which they just released last week, and it's available on Nebius Token Factory. We also made a few other changes to the harness. We added Langsmith for observability, and we added Snow Globe from Guardrails AI for user simulation and adversarial testing. And once we ran this particular configuration, we saw that the cost dropped a little bit further down to $24 for the run. And we saw that the runtime reduced pretty significantly from an hour down to 13 minutes. We also started using Langsmith's recommendations and data from Snow Globe's simulations to improve agent behavior. We were able to understand what the agent was doing, why it was doing, and we were able to steer the agent in the right direction. So at this point, not only was this agent performing well on this particular task, we also ran this agent and the other configurations over 120 different tasks with known ground truth. This particular configuration performed the best. It had nearly perfect recall. It had 20% higher precision. And it was about 70 to 80% cheaper than closed source models. So you'd believe that this is now production ready. It was, but we discovered another challenge, which is we could build and run this one agent, but how are we going to run hundreds of agents for hundreds of users in production? So we've solved for runtime and trust, and now we are looking at the challenge of operating at scale. Let's take a step back. Let's look at all 4 runs and find out what we discovered. So really, 3 things stood out. Number 1, this path from prototyping to production ready is not necessarily a linear one. It's actually a maturity curve. So every time we saw a problem and we solved it, we discovered new problems that needed new types of fixes and new types of tools. So in reality, the right stack or the right harness matters as much as the right model, because those both go in conjunction in creating the right agent outcomes. Second, open source models or open weight models are closing the gap pretty quickly. For most agentic tasks, open weight models work out of the box. We had no retraining or fine-tuning through the runs that we walked you through. And third, production ready is not the same as running and improving in production, especially when you're running hundreds and hundreds of copies of the agents. And that's the next frontier. And that's what I would like to talk with our panel about and dig in the next few minutes. So let me invite the panel. We have Julia Schottenstein from LangChain. Ash Ashutosh from Pinecone.
Okay.
Rotem Wise from Tavili. And Shreya Rajpal from Guardrails AI. Thanks for joining us. Shreya, I'd like to start with you. So in one of the runs, we saw that the agent went off scope when it started looking for other regulatory frameworks rather than just FDA. What are the things that are necessary to keep agents on scope, especially before you hit production?
Yeah, that's a really good question to start with. I think the interesting problem about agents specifically is that it's very hard to even know what the scope is or what out of scope looks like until you actually start deploying that agent, right? So as an example, when you started out building that agent, you wouldn't have expected that the failure mode you'd see first is, it pulling data from these other sources until you ran it on some data points, on some queries, and then you discovered, like, hey, this is where it's kind of going on off track. And that level of infinite surface area in the way that agents can fail is actually one of the key ways that building agents is different from building traditional software. And a lot of how we have a very opinionated take on how to solve this problem. And a lot of how we think about solving this infinite surface area problem is inspired from self-driving cars, which is where I used to work for many years. And in self-driving cars, similar problem space, right? Like the real world is infinite. And how you really think about solving it is simulation. So rather than building something, building an agent, then going out into production, and then waiting for some user to use it in an incorrect way and then see that failure in production. Instead, why can't we simulate a lot of different kinds of user queries before you ever hit production that mimic your real users and then also go off track in ways that you haven't seen before, and that'll help you anticipate all of the different ways that your agent can fail. So we've seen that pattern before in physical AI, in hardware systems work really well, and we've seen it, the foundation model labs and the frontier models use it a lot when they're building their models and their agents as well, and we've seen that pattern come about much more with, with the agent that, like you guys built, for example. Yeah.
Julia, would you believe that this agent steering, is it a orchestration challenge or is it an evaluation challenge? And particularly, not just about how do we catch that before hitting production, but how do we continue to monitor it when agents are in production?
I think orchestration and evaluation are really coupled. And the reason for that is what Shreya is describing is you're not writing your agent logic in deterministic code anymore. Instead, you're using a harness and an LLM that calls tools in a loop. And so you can't pinpoint a line of code that will tell you exactly how your agent is going to respond. And so the best way to know how your agent is doing is to write some evals or some assertions on how you expect your agent to perform. We talk a lot about this agent development lifecycle, which is very similar to the software development lifecycle in stages: the build, test, deploy, monitor. But it looks really different for agents because it's very unbounded. You take user input, which is very unknown in natural language, and agents themselves have infinite in response. And so you need to have a system to iterate very quickly through this agent development lifecycle. And so it's not only your orchestration problem or your evals problem, it's being able to test pre-prod and post-prod as well, and having visibility to really know how your agent is going to do when it gets finally in the hands of end users.
What metrics would you be looking for when you're running these simulations or even evaluations?
Yeah, good question. So I think there's some around, so broadly I would classify these metrics in, a couple of different categories. One is, product or performance metrics, which is the agent doing the thing that it's supposed to do? And the second big category is, more, I would say, like defensive. Is it causing any kind of harm that, you wouldn't kind of anticipate, right? So as an example, if it draws on sources that are incorrect or non-factual, that would be something where it's misleading the user, and it allows you to, not do the task very well. Same for other complex coding agents as an example, right, where they don't solve the task well. The other big categories: is it jailbreakable? Is it, can it cause certain harm? Can I cause it to violate its own guardrails, et cetera? So that's kind of the other big set of categories. I think there's a good starting point for how to think about your metrics, but one of the things I've seen people the actual workflow with how you come up with this is that you build an agent, have some opinion early on about how you care about success, but as you run it on more data, you actually see how it performs. Then you'll start tracking, maybe, my customer support agent hands off to a human too often. So it wasn't a metric that I knew of before, but when I actually look at the data, I will understand that this is a metric I now need to track. Similarly, maybe it's making too many tool calls or the cost is too high, so I can build metrics around that. But it's retrospectively after you actually look at the data and how it behaves.
Good. So adding both snow globe simulations and Lang-Smith's recommendations was a big boost to improving the accuracy of the agent. Switching gears a little bit, another big boost to the accuracy of the agent was when we added live grounding. So to me, that's where freshness of knowledge came up. And freshness of knowledge is a moving target. The knowledge outside in the world, away from the agent, is constantly changing. Rotem, what would you say is a way to monitor and maintain that the agent always has fresh knowledge? It seems like it's been a 2-year-old problem with some solutions. Yeah. You can tell us a little bit more.
Yes, I think real-time data is probably crucial to any agents today. I think just 2 years ago, you'd ask questions like, what's the weather today, or what's the score of the game last night? And the response you would get is, I'm sorry, my knowledge is cut off to 2021. I cannot answer that. And so I think the only people that are going to be happy today with this answer are going to be the Knicks fans, but that's, I'm a New Yorker. But really, the purpose of grounding initially was, okay, let's just connect models to the web, give them access to real-time information so they can at least answer the questions. But what we're seeing now is much, much bigger. When you connect AI to the web, it's not only you get fresher data or fresher answer, you really get a much better quality response. And to understand why it's happened, we need to really look at what's happening to the web today. So up until now, people used to communicate to the web directly, right? You're going to go on Google, you're going to send some emails. But what we're seeing today is that people communicate to agents, and they communicate to the web. And this shift is really splitting the internet, as we know, into two layers. One that is more human optimized, which is the internet you know today, and one that is more optimized for machine intelligence. And that's really the layer that we're working on. And thinking about this layer, there are 4 core pillars, which is tokens, efficiency that you need to optimize for, accuracy, freshness, as we said, and obviously latency. But by the way, different agents gonna need different trade-offs. Some agents, like deep research agents, gonna need to go for hours, sometimes days, it depends what the task, but I don't care how long you're gonna go, I just want 100% accuracy. But if you think about a car assistant voice agent, then latency is the most important pillar. So really, what we're building here at Tavili is something that's gonna give you this flexibility, and that's completely different than how human search is built today. And it creates a massive opportunity. You can turn hours of research into seconds. And just to give you a quick example, think that you're planning a trip to Italy, you're probably gonna go on Google, you're gonna search for locations, you're gonna search for events, you're gonna sign up, and you're gonna have to compile everything yourself. It can take you some minutes or hours. Agents can do it in seconds. It can process enormous amount of web data. It can synthesize it using LLM, and then it can produce a nice result. So eventually, it's creating a new paradigm. So more compute can directly translate into better search in this new era of web search.
You mentioned something really interesting around a new paradigm with this idea of 2 internets, right? One for agents, one for humans. Ash, I want to check in with you next, which is, so in one of the runs we saw that the agent consumed probably millions of tokens when it was retrieving information, and it reread the information that it had already retrieved from before. Do you believe that we need a retrieval system that is built for agents as the first-class consumers rather than humans or models?
Yeah, I think humans are, when you deal with machines, they're pretty forgiving. And if you look at Pinecone invented the whole idea of vector databases, allowed people to come back and use AI tools on those vector databases. And if you look at the evolution, 2022, ChatGPT came out, Pinecone went out and produced the most number of chatbots ever. But that was a consumer. They were very forgiving. You gave wrong answers, no big deal. You said, I don't know the result of Nix. That was okay. And then you went to the next level. By the time we got to 2023, enterprises started to come in. And enterprises are not so forgiving, but they're still human beings. In September last year, for the first time, we saw a new class of users who exceeded the number of API calls than humans, called agents. And they're not forgiving. They just take information as you give them, believe that's the information they have, and act on it. So this is not a problem of the LLM being bad. This is fundamentally a problem of a mismatch where you have asked agents to perform a task, but you gave it systems built for human beings. That's what we did.
Yeah.
For 4 years, we've been building for human beings, and this new class of users came in, and we had to fundamentally change that. And that's what we announced, Pinecone Nexus, May 4th, which is re-architecting the entire stuff we used to do for agents, very similar to what you talked about, 2 webs. I know the web, I heard last month was the first time the web traffic exceeded agent search than human. Enterprise exceeded September last year as they started maturing stuff. So we came up with a very different model where fundamentally Pinecone Nexus allows people to ask for three things, right? Agents need, one, an ability to express themselves on what their task is. Two, the ability to receive information in a model in a manner that agents understand, which is a structured way. I don't want a poem. I don't want your music. I just want you to give me a precise answer because I have a job to do. And third, frankly, to get to that millions of tokens and be able to do much more productive is where our partnership comes in. The ability to take Nexus, run it on a compute economic model that allows us to drive, I think we did the numbers with you, 91 to 95% reduction in tokens, 80% reduction in actual cost of running an agent with you guys. Now that's a business ROI I can justify, but it requires a very different underlying knowledge infrastructure, very different one than built for humans.
Yep.
I think that's what it is.
And just talking about the impact on business, so production-ready agent means that the production can be deployed. In production, agent means that now the business is dependent on it.
Yeah.
So Julia, what would you say what's the point where we cross this chasm, or what metrics do we need so that we can actually have agents run with autonomy, or enough autonomy, maybe with some human intervention, where we're able to trust the decisions that they're making at scale?
Yeah, well, we've been working with agents or trying to build agents for a really long time, almost coming up on 4 years now, which is a lifetime in this space. And now all we talk about is agents. That's the word we use. But last year we talked about agentic, and I really liked that term because it was more of a spectrum. When you started with your initial chatbots in 2023, there was not really anything agentic about it. People would talk about agentic RAG, where your LLM started making some corrective choices or had more decision power, but it wasn't an agent. It was really just a chatbot. Now, as we've moved on and the models become way more powerful, we have these new standards and interoperability. So you have agents and sub-agents, and you take action, and you delegate a lot of the tasks now to the model. You do start seeing more and more agents moving on that spectrum, going increasingly agentic. And really, it's not when is it ready to go into production. It really depends on the use case and the stakes. And we have used deep agents, which is a harness that is tool calling in a loop. A lot of enterprises still really want determinism, and so we have a different framework called Lane Graph that helps you, if you need these 3 steps to happen in this order 100% of the time, the most efficient way to do that is code, not an LLM. And so it really depends on the use case and what you're trying to accomplish, how much tolerance you have for delegating the task fully to the LLM. But if you are moving more to the agentic side, you really do need that full level of belt and suspenders approach. So it's the evals that we spoke about, it's the observability that we spoke about, you have guardrails. You fundamentally cannot trust these systems because they have non-determinism in them. And so depending on what your level of comfort is, the task, you're going to have different precautions in place to make sure that they are production ready, especially in high-stakes situations like enterprises where you're dealing with unforgiving end users.
Great. Let me skip forward to one more question. I think we're going to run out of time in a couple of minutes. But hot takes from each one of you. So we've got this one agent running, it's doing its job. We're going to put 100 agents in production now. What do you believe is the thing that's going to break first? We'll start with Julia.
Visibility. You're going to have no idea. It's going to be chaos.
Yeah. I would say knowledge. When one agent, you can manage errors manually. You can say, let me go recompile some stuff, re-index some stuff. 100 agents is a knowledge infrastructure problem. You cannot have 2 agents try to get some information and actually get it different. especially in enterprise. It better be consistent. And if you don't have that, you lose trust. And if you lose trust, you're never in production.
Good point.
Can I support LangChain and say visibility again?
No, you have to disagree.
It's not a hot take if we agree.
Yeah, but I also add on that eventually the biggest problem in AI today is search or organizational context layer, because companies that won't learn how to utilize their proprietary data, they're going to be left behind, because today that's their only moat. It's going to be in the game.
I will say, I'll also echo Julia and say, you won't know what's happening, but I will say that it's going to be very hard to, make updates to it. You'll have your agent, when you're running 100, it becomes very, very hard to know if, it's getting worse, it's getting better, how you should iterate on it. So just the ability as a developer to make it better becomes really hard at that scale.
So we have some agreement, but I still want to debate about this at drinks later. We'll talk more then. All right.
You asked us only for one. If you had asked us for 2 or 3, we probably would have agreed.
Next session. All right. Before we close, I want to leave everyone in the room with something you can use right when you walk out the door today. So everything that we built our agent with today, the production inference infrastructure, orchestration, observability, simulation, grounding, retrieval. These are essential layers that are necessary to build, run, and improve agents in production. And most teams have to reinvent this architecture when they're starting their journey. So today we are introducing Nebius Agents Blueprint. This is so that you don't have to start prototyping agents from scratch. And it's an open reference architecture, which means that you can go from prototyping agents to production-ready agents using recipes and runbooks that we've created. It's available on build.nebius.com/blueprints. With that, I want to bring our panel to a close. I want to mention one more thing, that all the products that are in this blueprint are built by folks who are representing here on the panel. So I would like to thank them for that. And I would also like to thank you for an incredible conversation. I'd also like to thank you for joining us again, and hope you guys have a great rest of the day. Thank you.
That was awesome. Thank you, Julia, Rotham, Ash, and Sharia, and Devang for providing us a wonderful panel on Agentic Inflection. By the way, blueprints are the very beginning. There's much more to come, and I think we all know that there's still a lot to build. And as we shared today, we're at that inflection as the market moves towards agentic. We're building towards what we are learning from customers and what we're gathering from our partners in order to be a big part of supporting what is going to be a major inflection in the market. So, as we begin to wrap up our first Nebius Inflection, one thing is clear to me. As we know, the opportunity in front of us is massive. But I think you heard this over and over again. It's just the beginning, and there's a significant amount of responsibility that we have to make it happen. The next chapter of AI will not be defined by what models can do. It'll be defined by what organizations can deploy, what enterprises can trust, what developers can build, and ultimately what users can depend on every single day. And if there is one conclusion from me today, from today's discussions, it is this: there's no way we're going to get this done alone. The path forward runs through rooms like this one, where humans are sharing what works, builders are being honest, and ecosystems are willing to commit to problems larger than any individual company. The spirit is exactly what we created, Inflection 4. The challenges ahead are real, but every major technology transformation has faced this moment. Each transformation has been driven forward by humans who refused to accept that difficult meant impossible. I hope you leave today with 3 convictions. That collaboration is not simply helpful, it's essential. That the challenges are significant, but achievable. And that the next era of agentic AI is already here, and each of us has a role to play in shaping it. Inflection is not really about an event. It's about a moment when an industry stops debating what comes next and starts being accountable for actually building it. When experimentation becomes execution. When individual innovation becomes collective progress. That is what we started here today. And that is why this is the beginning of an inflection we're happy to be a part of. On behalf of everyone at Nebius, by the way, these are their pictures, thank you for your partnership collectively, your leadership, and for being here. We hope to see you at the next inflection. Thank you.